Shit, hello guys. I got a notification. Okay. Fuck it. We are going like this. Alright, notification. No notification. I missed my thesis. I got a haircut. Let me see. Looks good. Okay, I look good. Let's go finish the video we were watching about ranking robots to fake users. Learning product rankings, robots to fake users. And yeah, then we may email Nadine and say, yo, what's up? We liked your paper and we want to know what's up in Amazon Hub in MIT. Is it Amazon Hub? Amazon Hub is where you return your items. But Amazon has something in MIT and we want to go there. So let's watch the video.
At least for some of the levels, I'm going to artificially limit the number of fake users they see, and I'm going to use that artificial number to kind of enlarge the confidence interval. These are the two ideas. Okay. So idea one, this is about like targeting different conservatism level. So for that one, I'm going to keep multiple copies of the 4 algorithms, meaning that each of these 4 algorithms are going to have their own confidence interval, their own graph. But when let me not tell you by how much I'm going to widen the confidence interval yet. But there's some widening of the confidence interval happening. So I'm going to have 4 in level 1, level 2, up to like level L, which is log T. So every time when I want to make a decision, I'm going to choose one of these levels at random and follow the recommendation of that particular algorithm. So what am I trying to achieve here? Because if they're like the same copy of the 4 algorithm, why having multiple levels even helping? So what am I trying to achieve here is that I want to make sure that these algorithms target different conservatism level. And to do that, I'm going to choose them with different probabilities. So with probability half, I'm going to go with the 4 in level 1. With probability 1/4, I'm going to go with level 2, up to like here with probability 1/2 to the power of L. I'm just going to go with the last level. And now, as I'm going from this level 1 to level L, these levels see less corrupted data points because I don't like really actually passing any data points to them. I actually use them with a very small probability. So they also see very few corrupted data points, which is really good. They're going to be slow learners, but they're also going to be more conservative. Okay? And that's like having different probabilities allows me to have like different conservatism level in a very implicit way. Now, what's the second idea? The second idea is about artificially limiting the number of fake users, at least for some of the levels. And that's based on this simple lemma that says, for any level greater than L star log F, these levels are not going to see more than log T number of fake users. Okay? So, and that's because like I don't really invoke these levels with high probability. So as a result, at most these levels are going to see log T fake users. So then why this is helpful? This is helpful because now in all of these 4 algorithms, I'm going to use that log T to enlarge the confidence interval. And at least I know if I do that for these higher levels, this is the right level of conservatism. And if I do that by the proof of the 4 algorithm, I know that whatever decision these levels make for adding edges, they're going to be correct edges. Okay. So that's take care of these higher levels, making sure that they don't make a lot of mistakes in terms they don't make it with high probability, they don't make mistakes. But there are still 2 main questions. First thing is that, okay, so now you tell me that high levels are okay because when it comes to widening the confidence interval, you use the right factor. But what about these low levels? Because most of the time you are actually invoking them. With higher probability, you are invoking them. So how can I make sure that these lower levels also learn the correct edges? That's the first question. The second question is that, Okay, higher levels, I know they don't see a lot of corrupted data
How
points.
do we make sure lower levels learn the correct edges? What are the edges? They may expose too many fake clicks. High levels can be too slow to learn the correct graph. Can we make them faster? What is the graph? Boop 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 boop. Go back, go back, go back, go back, go back, go back, go go back, go back, go back. 5 second, 5 second, 5 second. A lot of layers, 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 years, 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 5 years, 5 years, PhD, PhD, PhD. 5 years PhD. Layers, layers for fake aware ranking. Bang, bang, bang. Okay, I don't remember, but it doesn't matter because this whole paper. We just wanted to get to know what she was working about. We don't care about the details.
Cross learning. So any edges that I
Because
have at level N, I'm going to transfer it to the lower level.
at the moment,
so here's an example.
we don't care about them.
I know that
And
level 2
hopefully
is
we
more
never
conservative
care
than
about
level
them.
1. And
I know
suppose that
it
this
may
level 2 end up adding an edge between like product I and J.
upset some people,
I'm just going to literally transfer this
but
edge
that's what it is.
to the level 1 as well. And that's by doing that, I make sure that these lower levels also learn the correct edges. The second idea is upward cross-learning, which was actually a novel aspect of the design, and that helped us to get the regret we wanted. So that upward cross-learning is about related to the second question, because in the second question, we were worried about the higher levels learn things at a very slow rate. So in upward cross-learning, when we get samples at this level 1 to L minus 1, we somehow transfer them to the level L with some factor. We are not going to transfer all of them, but with some factor we do transfer.
Assume we were reading this
the way
paper.
that you can
That
visualize
would be
it.
like a huge
So based on these two ideas, we managed to answer these two questions
waste
that
of
I
time.
raised earlier on. And that leads us to this theorem that the fork algorithm incurs regret in the order of n square f.
However,
so let me pause here to see if there are any questions. Yes.
Taking a look at their model and how they model I think we looked at it, by the way, right? Or we didn't. So their problem has a lot of other layers because they
so if
are.
I use a sample, it's also possible that all these higher
considering,
levels see all the, for example, even up to f number of fake users. But then if that happens, I cannot really say that high levels make the decision with right decision with the high probability. Because if you remember, I needed to enlarge the confidence interval for this for these levels. I did not know f, but at least I knew that these high levels are going to see at most this log t fake user in average. So then for these levels, if I go and enlarge the confidence interval by this factor, theoretically, I can say that any level greater than L star, they are going to make the right decision when it comes to adding the edges in the graph. But if I transfer all the samples to them, that would I can would corrupt these higher levels, so then I can no longer say that these are making correct edges with high probability. Yes. No, there are parallel algorithms. They're there, and then every time I flip a coin, I do and I choose one of these algorithm, one of these levels with some probability, and they're evolving on their own. The only way that these levels communicate with each other is through this downward cross-learning and upward cross-learning. But think about it as a parallel copy of the same FAR algorithm, with the difference of their confidence interval is not being enlarged by the factor proportional to f, but is being enlarged by factor proportional to log t. Yes. Yeah, I think like when we first started working on this problem, I thought like maybe this is related to mean being more robust to median, median being more robust than mean. So then we actually started to think about like what if I try to instead of estimating the kind of the click probability, try to learn the median, it didn't help as much. I'm not saying we took that route, it didn't help us in the design, but yeah, that there's connection. Yes.
I don't know why
Yeah,
my
exactly. So I
leg,
like, for example, think about this level.
my ankle is suddenly gets a scar on it. I don't remember where I hit it. It's just, and like the bleeding is over. And probably 2 days after bleeding, I get to know that, oh, I had this scar. Shit. My toenail. Fuck, this is scary. I gotta wait. Fell over my toenail and it broke it. Actually, I think it's getting better in a sense. Or it is not. It looks healthier. When was it? Wow, it was a year ago. Guys, it was a year ago when my dad was here. By the way, it's my birthday today. Shit. And it doesn't look much better. A year passed. Because like underneath the toe, the nail, like between the toe and the nail, there are a lot of naily stuff, but they're not nail. I don't know, but I think now they are moving slowly forward, which is good.
This level L star, this level is being like chosen with probability 1 over f. And if there are even at most f number of x, there kind of in expectation this level is supposed to see constant number, or even like in the worst case log t if you go with the concentration inequalities. So there are like
Finish this shit,
with a
dude.
small probability. And then as a result, they don't see a lot of corrupted data. So they could be a slow. That's why upward cross learning was quite essential for us to kind of.
Honestly, I don't. I'm sorry. I don't like the academia this way. I think we are missing
Yeah, even like for
points.
this one is like 1 over f times f would be constant. So then it's kind of if you want to kind of have an extra buffer for the concentration inequality to go through, you need an extra log t.
None of the people in this seminar.
Okay.
Probably none of them.
Yeah, and then so after the design, we asked ourselves, okay, let's actually do some simulation.
They don't know about. They cannot do anything with this information other than publishing papers.
UCB in like a more generalized instances, not even the stylized example that I talk about.
Wow, UCB has a linear regret.
It's linear regret. It's not really robust. By the way, this is regret, so the lower the better. So, and this is for algorithm regret of 4. This is the regret of fork algorithm. And
nice. Like she did a good job. Look at their algorithms.
The reason that we think is what's happening, like we observe this, is that
look.
Maybe.
Well, I am nagging all the time, but do you have me? Yeah. Look at this. So the regret with UCB, which is a common learning algorithm, is like this, linear. Regret is linear. And you know, guys, regret hurts the most. Just a pain in the ass you will never forget. And they made it this good. Like we had the far. Far is also good. And the fork is even better. Honestly. But you know what it makes it amazing? You apply this algorithm and see how it works. That's amazing. That's wait a second. Where do they get this simulation from, by the way? I don't know how.
Because we wanted to get the theoretical result, we enlarged the confidence interval for that algorithm by too much. Ended up like being too conservative and quite not decisive. So if the confidence interval is like way too large, the algorithm is not making any decision for a long time. But fork algorithm does not have that. It's kind of, and maybe without knowing if it hits the right level of conservatism and even like manages to do well and outperform the for algorithm, which is I think is a good news, because in most cases we are going to be in that scenario, right? So now we say that don't need, as a platform, you don't need to go and estimate f or have a good upper bound for f. Just run this fork algorithm, which is like fake oblivious, and then you are going to get good results.
Oblivious.
So we also like try to understand the impact of this upward cross learning, because upward cross learning was kind of the novel aspect of
Actually, I think everybody in academia likes their projects, their papers to be applied in real life and see the result. But because there is no connection, there is no commitment from this like Amazon or stuff. Even when I was in my, okay, that's good, that's academia. Even I was in Clubhouse, we were doing a project because they have so many projects to do. Even if you come up with a solution, it's not guaranteed that that solution will be implemented, because that is also part of the nature of the shed of research, and that you cannot apply it and see the result of your work all the time. I also talked to a guy in Google, they say this is the same. And also somebody in Netflix, like they have data scientists and data engineers, I guess. Data scientists come up with this algorithm. Data engineers say, oh, this is not implementable. It is even good, like it is good, they at least say this is not implementable. But sometimes you come up with an algorithm and we don't have time to implement it, because like in a week our priorities change, something like that.
Show the regret. So here I compare fork with like 4 minus, which is the fork with downward cross learning but no upward cross learning. And we observe that even in the simulation, it's having upward cross learning is going to give an edge to the algorithm, and it's going to reduce the.
I think everybody loves their paper.
We were not able to manage
to
show that 4 minus is going to get a linear regret, or like theoretically show that 4 minus is worse than 4, but nonetheless the numerical result shows that upward cross learning is quite essential.
Guys, do not look at your phone.
Okay,
I have like 3 notifications.
Let me summarize.
Let it go. Once it is finished, we will check.
That many online platforms want to make decisions
not this,
with their data,
like,
use machine learning algorithms.
I want to also email
problems in the presence of fake users. We show that if you go with traditional learning algorithm like UCB, those algorithms tend to be quite fragile, and they can be easily tricked. So then we designed 2 learning algorithms.
Even UCB was very good. Like I was comparing UCB with daily life, right? I think in UCB, once in a while you do something new, and most of the time you do the things that you like the most, but there are times that you do something new, and that sounds like a good mindset to have. But they studied and said UCB, even UCB, which is good, is not that good, and they come up with better algorithms that minimizes the regret. Well, if they're not complicated, it is nice to apply them in your daily life.
Which widen the confidence interval and use this pairwise relationship graph to make decision. And then the second one was fork that leverage this multi-level learning algorithm and this bidirectional cross-learning between different levels. So I did not talk about, but we also have this result that says, okay, what if I make sure that fake users are not really bursting, but they are spread out? Because in many cases, these like fake users are being hired by someone to kind of create these fake clicks, and maybe they have limited budget that they try to spread over time. For that one, we show that the same algorithms can get can do much better if the fake users are kind of spread out. And at a very high level, I think hopefully this work can be used for various other settings when you have like spam reviews or fake likes or even like fake purchases. And maybe like being
all of the likes are fake.
It's going to be
No,
in other
like
settings,
my
like
videos.
taxation and
I take them
recommendation,
seriously.
As well. So with that, I'm just going to wrap up the talk. Thank you so much for listening to my talk, and I will take any question that you might have. Thank you.
Let's go email. Let's go email right away. Okay, let's listen to some of the questions maybe.
Yes.
Is fake or not? You get some, but maybe the prediction itself could be fake, like wrong.
So I think that's a very good question. We have an ongoing work in which we try to combine detection with learning. So because let's say you have a detection algorithm, and detection algorithm would give you a score, how confident the algorithm is about this user being fake or not. This is an ongoing work. I don't know. We are really hoping that we can kind of, by leveraging detection, by combining these two, we can achieve better result. But that's a very good question.
I have to clip my toenails.
When you're looking for a product, they throw in things which are kind of related, but not along that line. In other words, to attract the attention, maybe the user does not know exactly what they want, or they might be interested in something else, and then you throw that in, and then it may attract attention, and they'll click on it and buy it, even though that was not their intention. Is there anything of that sort that can be accommodated?
I think not in this one, but I have another paper on product ranking, and over there actually we say the same thing. So sometimes like user may not really know what they're looking for, and in that case maybe even going
Which
with
one did you study?
kind of score-based or popularity-based ranking may not be the optimal
This
thing,
is
because
robust
you
to
wanna
fake
throw
users,
something
but
within
she has also a
the top
paper on
position
product
in order
ranking.
for the user to see, and maybe that's become the favorite item for that particular user. And we have the result that under like some setting, it's like popularity-based ranking may not be optimal even for the user themselves. Maybe there's a way to kind of combine that result for this one to make it also robust, but that's a very good question.
Thank you.
Okay.
So I just heard a talk a couple of weeks ago by somebody from Amazon. I think they have two pieces of information about clicking. One is whether somebody clicks on the product, and the second thing is whether they follow up and buy the product. So these two are correlated, but they have two pieces of information. I would assume that fake users would not be buying the product; they'd probably just click on it. So I wonder if that could be helpful in sort of figuring out who is fake, whether that can reduce the regret.
So I actually have thought about that. So in many cases, you have more than one signal. This is why I use clicks, but sometimes you may have also fake reviews or fake purchases. And actually, fake purchases are real. So especially if the Amazon does not fulfill the order, so someone would click that I purchased, and like kind of nothing will be shipped, but then that imaginary, like this user also end up like writing like a fake review on that. But nonetheless, like creating fake purchases is more costly than creating fake clicks. Fake clicks is like a very cheap thing to do. And then maybe one idea is that how can I like combine various signals that the cost of manipulation are kind of heterogeneous. Some of us more costly than others, but they still be robust. I can believe that in such a case, maybe using the signals that are less costly would be helpful, but such a signal is also sparse, right? So maybe you get a lot of click data, but not a lot of purchase data. So that's why maybe it's better to combine them rather than only relying on the purchase data, which is not going to be sparse enough. But yeah, this is a direction that could be like interesting for future.
What happened to my throat? I don't know.
So, if you were to subsample the history, so if F is small relative to T, if I were to just subsample and discard some of the data points over time, and then use something like UCB, would that also help in reducing the regret?
So if really a small, okay. So you're saying if it's a small and then I kind of remove the data at the beginning and then...
Not at the beginning, randomly sample.
Randomly sample the data. Randomly sample the data and then throw away the rest of the data?
I mean, just the idea is to basically remove, use a subset of the data with the hopes that over time the weight of the non-fake reviews is going to be higher.
I don't know if
she
the
has
sample
one.
will give you the regret that you want, but at the very high level, randomization is usually like the way to go. Also, in that design, we had this randomization over levels that allow us to kind of get the regret we want, but maybe for your randomization to work out, you need to know F, because you would know that it's what, without that, maybe it's not very clear.
I mean, she has a paper,
Thank you so much, thank you.
product ranking on online platforms. Where is the paper?
Welcome everyone to the afternoon session.
The fuck? Also, Wahab Miruknizan. Wait a second, you're not with me, or you are? Control Shift 2. Now you joined. So this is another paper, product ranking on online platform. This is a short paper. This is a paper we can take a look at. And actually, it is something we should look at. Don't study hard, guys. Even if Richard Feynman says he's wrong. Study smart, which means study less. It's a playlist for programmers. Oh shit. Yeah, I want to code. Let's go. Class, function, structure, list. Stanford Online, Chat GPT. Oh, it's here. Found it, guys. Oh, it has a video. Oh my god. What is this? Alright, why should this come in the search? Why is it for me? I don't expect it to show up in this Chrome. I made this Chrome very safe. Healthy. Alright, this one.
With DataCamp, you don't need to download Python to learn Python. You can learn right in your browser with hands-on exercises for
So thank you everyone for attending this talk. Today I'm going to talk about product ranking on online platforms. And this is a joint work with Mahsa Dirakhshan from University of Maryland, Vahide from Yale, and Zahab Mirukni from Google.
2020.
Okay, I'm going to start this talk with one of my online shopping experiences. So when I moved from California to the East Coast, I really wanted to buy a pair of
UGG slippers, boots, are they really beautiful? If I was Amazon, I wouldn't put them even on my website.
Slippers. So I went to Amazon and I searched for a pair, and Amazon showed me more than 43,000 search results arranged in 400 pages.
400
so as you
pages.
can imagine, I didn't have time to go over all of these like 43,000 search
Actually,
results.
I think the page 400 may get some views.
Appearing in the first page, and I purchased something, and it wasn't that bad after all. Actually, to this day, I like the pair that I ended up purchasing. So apparently, I'm not the only consumer that is very selective and looks at a few set of products to make a purchase. According to Millward Brown, which is one of the largest market research company, 70% of Amazon users do not even bother going to the second page of search result, yet alone going to page 400.
Let me know
So
what kind
this
of
highlights
Amazon
two
user
important
you are.
issues. The first thing is that on online platform, most of the products are going to be invisible to the consumers. And then the second important issue is that the products that are placed in better position, for example, those that are placed in the first page, are going to be more visible to the consumer, and as a result, they are going to have a higher chance of getting purchased. So keep these two things in your mind, and now let me show you more evidence that highlights the impact of positions on consumers' behavior. So we had access to query level data from a large online platform, and by analyzing that data set,
Okay,
we got
that's an interesting graph. So we have one random ranking and another one platforms ranking. Random ranking means we just choose a random permutation, right? And the x-axis is the position. Wow, this is crazy. This graph is crazy. Do you see that? This is, oh my god. This is this is crazy, guys. It means probability of click. If you're on the top of the list, even you have the worst quality, the odds of you being bought is far higher than the second one. Like, it means a random ranking and a platform's ranking, which probably means, yo, as a platform, I try to put the ones with higher quality on the top of the list. Well, it's not the only factor I care about, but it shows itself in the platforms ranking, right? That permutation and any random permutation the probability of you being clicked more than anything else, it seems from this graph, depends on your position on the list, and not at all on your quality. On the rand, that was it was genius. They said how to show that in the best way, that your position on the list matters, because it's all about your rank, and even a random rank doesn't have much difference from the platform's rank.
This figure that shows probability of click versus positions under two different rankings. Random ranking, which is the blue one, and the platform's ranking, which is the red one. So one thing which is interesting here is that even under random ranking, we can see that the probability of click decreases with position. So, and then another interesting finding is that we can see the probability of click.
Damn, guys, I really love this project now. I think we can find good. Well, this paper seems to answer a lot of things. We want to understand this. This paper, like contrary to the other one, which was about fake users. Well, it's an important problem because she knows that it matters to Amazon. And from that point of view, it's interesting. From my point of view, it may be a bit far because I just want to get to the idea of the ranking and stuff. But maybe I go, if I can connect with people in Amazon, then I have to find another problem. Maybe it's about pay, but it's something that matters, right? I want to do that. This one sounds like a basic thing, basic ranking problem from the title, that I like to know. This title is closer, more relatable.
It's actually higher on the random ranking compared to the platform's ranking. So you may wonder why actually this is happening. So the main reason for this finding, we believe, is that on the random ranking, it's very likely that the products that you see, that the consumers see on the top position, are not going to be really relevant, and that's going to motivate the consumer to scroll down further the page and then see more products. And based on this,
Yep.
we can say that the products that we place in the top position impose some externality on the products in the lower position, and that's why the probability of click is actually decreasing. And more importantly, the better the products that you put in the top position,
externality. I like externality. Externality is one of the things I like to study.
More products. And based on this, we can say that the products that we place in the top position impose some externality on the products in the lower position, and that's why the probability of click is actually decreasing. And more importantly, the better the products.
Dude, if you are not on the top of the list, it looks like you don't exist. That's how stupid it is.
The higher the externality. And that's why the probability of click in
Wow.
lower position is actually
That's
higher
crazy.
on the random ranking. Okay, so based on these
So you may
observations,
go
here's our
work,
main.
produce the best product. But if you're not on the Amazon's list, going on Amazon, what's the point of going on Amazon? Does Amazon charge every I remember it was pay-per-click. So at the beginning, it seems to me, at the beginning, your marketing matters far more than your quality of your product. And maybe even better, you sell some lower quality product, and then with lower price, buy a lot of sponsorship at the beginning, and then you get that enough attention. In next rounds, you can, once you are seen enough, once you get a good score on the platform, you can work on your quality. At the beginning, your quality should not be very strong. Well, if it is good, but at the beginning you need to focus on marketing more. Once you get a good score on the ranking, then you can go, okay, I want to even make a better product, because yeah, I think the quality of the product is something that separates you from the other people, other products that are around you in the ranking, you know? Yeah, for example, if you're in the top 5, your product quality matters. But if you're on ranking 500 and another guy is rank 1 or top 5, and the top 5 guys' quality may be lower than you because you haven't worked on the marketing.
In research questions, we want to understand how should the
And I want to
platform
know,
rank
okay,
the products
one
given-
question I like to know is that how to enter a market. Well, platform, we need to know the algorithm of the platform, but how to enter a market that already, is it worth to enter into a competition that the platform already is settled with the ranking, right? There are so many products there, those companies are settled, they are on the top of the list. Is it worth to get into this competition with those? Can we get to win, or we should even better like keep our mark? Well, yeah. Also Amazon, when or also YouTube even, I guess, or Google or anything, when you search and when you buy a sponsorship, they say that you bought the sponsorship. In a sense, it says, okay, you are not good, but you paid to be seen. I don't know if it's a good signal. I usually take it as a bad signal. But what if they don't tell us that they bought a sponsorship to be seen? One thing is this. One thing is it worth entering a market? Let me write them down. The questions I'm interested in. And in many of these questions, actually, we may have a solution, right? What is this one? I see. We may have a solution. That we may have a solution that is not proven theoretically, and to be honest, if there is a solution that works, I prefer not to study it in a theoretical manner, because at the end of the, I want to answer a question that people don't have an answer. Yeah, maybe you say, okay, we will solve this problem, we already, people have some intuitive solution for it, and they know what to do when they enter the market, they know how to buy a sponsorship, how to focus on quality or marketing, right? And okay, you may say, okay, if you study it, you may find a solution that gives us utilities or revenues or payoffs that are far better than these intuitive solutions. But I don't want to invest on that. I think it's a very narrow chance that this happens. Other thing is that yeah, I prefer to find a solution that people don't know what to do about the things they have a solution, they already have a strategy. I don't want to care. I want to find a question that people in this ranking world don't know what to do about, not come up with a better solution for a strategy that they already have. Yeah, that's a good way. I want to write them down. So, one question. We are out. I also share this. What happened to my head? Um, that's it. We are interested about in. Is it in, right? In one, we want to find a question that people do not know how to deal with. Not a question that they already already have a strategy for it. They already have a strategy for it, and it works good enough. Not a question that they already have a strategy for it and it works good enough, and we try to find a better solution. If they have a strategy that doesn't work, I'm interested in find a better solution. Okay, these are the two for my understanding, to my interest. Um, what are them? how much quality matters, quality versus marketing. Quality versus marketing. 3, how to enter a, is it worse to enter a platform that is already settled? That can be people's question. For what is for? Can be, yeah, like can a product who is in like page 400, not for, okay, for example, for 5. What can that strategy, what can that not platform, firm or company, product, what a strategy that product can choose to go up to? Once your score is low, is there any hope to bring it up? What else? Oh, 5. What if Amazon do not show the sponsored tag? Well, I don't know if having it does. Is having sponsor tag bad or good? I feel it is a bit bad, but who knows? Maybe somebody say, oh, they are buying the tag, so they are investing on themselves. They are saying, yeah, you have a good quality product. A low quality product may not invest on marketing as well. Okay, let's go the rest of the. By the way, I have to add this stuff that we did. Add them to my things that I did, so that we can celebrate it later. You may come here and say, oh, what did we do last time? I don't remember what I did. I did nothing. No, write these things you did down, so that you have things to say. You say, oh, I did this thing, I did that thing, I emailed Negin. What is that thing you don't want to talk about? Okay, 1, we wrote a code, we did the coding. 2, ranking robust to fake users. 3, product ranking on online product ranking on online platforms. 4, what was 4? Product ranking on online platforms, and 4, I want to mention Amazon and MIT. I want to mention email, Negi, and talk. That's it. So we will do this stuff. Also, let me download this email paper. For these. Yeah, I want to buy a microphone, by the way. تولدمه. It's my birthday, by the way. Send your likes and let me know how will we do as an armchair theorist in the new year. تولدمه. سلامت پدرم. All right. Product ranking on online platform. Platforms. I download these papers and I read none of them. I'm just download. Does quality improve with customer voice? What does that mean? EC is an interesting it's a conference. And let me delete the other paper. Let's go to the main page, product ranking on online platforms. We are going to move it to my projects. Where in the project? In the thesis file, right here, move it. And we want to read this one because this one is 18 pages. That's what the paper is about.
And the consumer search behavior, and then considering the fact that the products in the top position impose externality on the products in the lower position. So what you are going to see in this talk is as follows. So first, I'm going to present a two-stage consumer search model that can capture products externality and consumer search behavior. And then for that model that we propose, I'm going to characterize the consumer optimal search strategy. Then after that, I'm going to focus on the platforms problem, which is a ranking problem under two different objectives that we consider. One is market share, which is the probability of purchasing something on that platform. And then the other one is the consumer welfare. So we show that both of these
Wow,
problems are
guys,
NP.
interesting. This video, is this listing for me? Yeah. Why should it be on the top of the list? Who is this? Hmm. Where? My God.
And because of that, we focus on approximation algorithm. We develop a p-task for this problem, and we also analyze the performance.
Guys, I got. Yeah, let's pause for a bit. I will take a break, come back, we will finish this part. And we may even go read the paper because this part is getting really interesting to me. Control Shift. How did I pause it here? Guys, I am back. Guys, I am back. Oh, lost the voice. Oh, let's go, guys. Finally, we found the fucking paper. The paper that tells us what is done so far, what will be done in the future, what has been done in the past, and what will be our contribution to the field. Woo! Let's go.
Performance of a simple greedy algorithm. Okay. So here's our model. We have n products that we indexed by I, and we have n position indexed by j.
Makes
And
sense.
position
Which
with the
n
small
is 7.
indices have more visibility. So for example,
Look. If you are also following me on the coding playlist, that's the difference. That's the difference between a human being who understands what she's saying and a stupid programmer that starts counting from 0. Nobody starts counting from 0. If it means that you haven't studied history. Human beings started counting from 1, and this is the definition of the number. So you should start from 1. For sure this paper kills. For sure this paper is the best. For sure this paper is a paper I read and I say, wow, dog, that was amazing.
position 1 is the most visible position. So platform is going to display these products to a consumer in form of an ordering. In other words, the platform decision is a
I
permutation.
told you about
problem.
permutation.
And here is, for example,
I knew that
I'm
shit.
just going to show you
It's
an
coming.
example of such permutation. Okay, so the platform objective
By the way, why
function
didn't
when it
she
comes
use the rainbow colors? We have 7 colors in the rainbow. Is that indigo? 6 is indigo. She could easily use that, but she didn't. Is there any message right there?
to this ranking decision it can be like 2 things. One is maximum.
I judge people based on what they don't do.
Okay, so the platform objective function when it comes to this ranking decision it can be like 2 things. One is maximizing its market share, where the market share is the probability that the consumer takes the desired action. Where the desired action can be clicking on something, purchasing a product, or installing an app. But then in the rest of the talk, just to simplify things, whenever I'm talking about market share, I'm just assuming that I'm maximizing the probability of purchase. And then the second objective function is maximizing consumer welfare. So we focus on these two objectives because we think that online platforms mainly care about their long-term objective, and because they want to make sure that the consumers keep
Market
coming back to
share.
their platform. And
That's
then
a nice word. I had it in one of my papers. Oh, so we have two platforms. No, we have. Wait a second. What does she mean by two platform objectives? Okay, so we have N products or N firms. That's then platforms displays these products. So there is one platform. There are no. So platform can have two objectives. Either we are interested in maximizing the market share, or we are interested in maximizing consumers' welfare. And she then tries to solve both of them. A platform cannot have two objectives at the same time. Right? So it means that she wants to solve these two problems.
Focusing on these two objectives, we believe that the platforms can achieve their final, their long-term business goal.
I'm so, by the way,
Fortune is my
guys,
best friend.
I am nagging like a bitch all the time on this channel.
I'm not just talking about grammar.
But really, this channel, ACMC.com, that's so good. Like, people put their presentations here. And it is, to be honest, better than reading a paper. I believe papers may be necessary, but we should have other form of presentation of our results too, especially these days, because we don't have time to read all these papers. Even I believe we should have a TikTok video, like 1 minute short video. What is this paper about? Then if you are interested, you go deeper, 5-minute video. Then you go like maybe even 1 hour video. Then you may go say, okay, I want to read the paper too. We need to have this hierarchy in academia, hierarchy of presentation.
Okay, so now let me walk you through our two-stage search model. And I'm gonna start with explaining how we model the utility of each product I. So the utility of each product I can be written as two terms.
Oh my god, utility of each product. What is WI, what is ZI? One YWI should have a log behind.
First term, which is the log of WI that we refer to as preference weight
They
of product
themselves titled it Twisted Search. Twisted Search. Why do you make a model that is twisted?
It's called
mental
intrinsic
masturbation.
This is the part of utility which is the same across all the consumers.
Every day.
The second term is the idiosyncratic part of the utility
every day.
consumer.
Mental
The log of
masturbate,
WI that we refer to written as two terms. The first term, the utility explaining how we model the utility of each product I. So I'm gonna start with explaining how we model the utility of each product I. So the utility of each product I can be written as two terms. The first term, which is the log of WI that we refer to as preference weight of product I, is called intrinsic utility. This is the part of utility which is the same across all
I missed their main moment. I got distracted, guys.
Their final, through our two-stage search model.
So we have two. I want to see, my ears should be sharp for when she says WI or ZI.
I'm gonna start with explaining how we model the utility of each product I. So the utility of each.
When you get a fade, it feels so good. Just touching my head feels good, dude. Oh, fuck. Alright.
Product I can be written as two terms. The first term, which is the log of WI that we refer to as preference weight of product I, is called intrinsic utility. This is the part of utility
I didn't get it again. Okay, it's an intrinsic utility. Log of WI is intrinsic utility.
Across all the consumer. And the second term is the idiosyncratic part of the utility that is different across consumer. And
Wait, idiosyncratic, does it mean it is common or is it I think idiosyncratic means personalized to everywhere, to each product. Let me check. Yes, it should be. Individual.
We put it there to capture the idiosyncratic tastes of different consumers. So WI, or these preference base, are drawn from some distribution f of W, and ZI is drawn from from the Gumbel distribution. And for those of you who are familiar
What
with
is Gumbel?
planning literature, from some distribution f of W, and ZI is drawn from the Gumbel distribution.
What is Gumbel distribution? I don't know what Gumbel distribution. How did you decide to choose it? Gumbo. So it is like what is this kind of the chi-squared PDF? Oh, okay. Ooh, what a complicated. Look at this. E to the minus z plus e minus z. This is a fucking distribution. And very strange to choose. It must have good properties. Hopefully. I want to know if it's generalization of another. Guys, you can't believe when we submitted the paper for Gaussian to one of the, it was actually EC. These motherfuckers, EC referees, they were saying, why did you choose Gaussian distribution? By the way, that person obviously was not from an econ background, he was computer science background. Anyways, now in this paper they are using Gumbel distribution, which is very weird. But to be honest, if I was the referee, I say, yeah, let's see how it works with Gumbel distribution. And if you fuck it, reader are more interested, go move your ass and write it in the general form. Look, it's a meaningful distribution. It has a nice look. Other distributions which are positive, they are just, yeah, you want something to start from 0 and go as a saturation point here and there and go to 1. That's what you want. I don't know, like it is the same as Gaussian. Look at this one. Pretty much looks like a Gaussian. We are allowed to have errors, guys. We are not, yes, we use math and we are very like rigorous and exact. But fuck math, we are engineers. At the end of the day, we have errors. Everybody knows we have errors. So fuck it, let's have more errors. They may cancel each other out, yes. Randomness and summer and sigma and variance go high and and fuck off. Who cares? At the end it should work. I wanna what is it? Celebrate? No. I wanna, yeah, clap. I forgot the word. I don't even know the word in Persian. She was brave. She was brave for choosing this distribution. Even if she chose it because it made the problem simple. Yes, you choose a fucking distribution to make the problem so simple because you want to find the intuition from the solution. You don't want to say, this is my solution, put it into your algorithm. Maybe sometimes you want to do that, but intuitions are more important. And she solved it for this. She's so brave for doing it. And I want to like this video right here. That's it. Did you see the like?
And for those of you who are familiar with assortment planning literature, so Gumbel distribution is pretty common in that literature. So both of distribution are common knowledge. Platforms and consumers are aware of these distributions. But what is important here is that consumer neither knows WI nor ZI. And the reason we made that assumption
Guys,
is
keep
actually
the
going
phone
back to the
away.
example.
Just you see a message, the whole changed, everything changed. Now I just got somewhere else. Fuck you. I hope you die in your grave, motherfucker. Who was his name? Steve Jobs. Leave me alone. All right.
Assumption is actually goes back to the example that I showed you earlier. So in my
I get angry, but it's not Steve Jobs' problem. He's dead already. But I cannot control myself, make other people guilty.
shopping experience, Amazon.
He was so nice. He made fucking iPhone. We are using it, taking photos, sending message to our friends. Just because I cannot control my thumb, really, just it is a muscle memory. Naturally grabs that shit and watches inside it. It is muscle memory. I don't have control. I just notice when I'm 30 minutes deep inside the video, I notice that fuck, I lost my focus. Anyways, keep that fucking thing away from you.
Told me like 40
while you are working.
And it's kind of like for such setting, it makes sense that we assume the consumer does not have any idea or doesn't have any information about any of the products that he or she is supposed to see. But the platform.
Oh, okay, now it's good. Wait a second. What is log WI and what is ZI in the example? Consumer neither knows WI nor ZI. Platform knows WI. Well, what are they? Is log WI plus ZI their score? Utility of each product. What does it mean? Product is not utility. Does she mean utility of each firm? Okay, let me start here again.
Okay, so now let me walk you through our two-stage search model. And I'm gonna start with explaining how we model the utility of each product I. So the utility of each product I can be written as two terms. The first term, which is the log of WI that we refer it to as preference weight of product I, is called intrinsic utility. This is the part of utility which is the same across all the consumer. And the second term is the idiosyncratic part of the utility that is different across consumer.
Wait, I don't get it. When she says utility, how can the utility be something random? Usually in game theory, utility is something that you take action and other people, like players, take action. Based on their action, your utility will be realized. Well, it can have random parts, but
and we put it there to capture the idiosyncratic tastes of different consumers. So WI or these preference weights are drawn from some distribution f of W, and ZI is drawn from some from the Gumbel distribution. And for those of you who are familiar with assortment planning literature, so Gumbel distribution is pretty common in that literature. So both of distribution are common knowledge. Platforms and consumers are aware of these distributions. But what is important here is that consumer neither knows WI nor ZI. And the reason we made that assumption is actually goes back to the example that I showed you earlier. So in my own personal shopping experience, Amazon showed me like 43,000 search results, and it's kind of like
I'm getting distracted. I need to fucking
such
watch this,
setting,
watch this, watch this.
it makes sense that we assume the consumer does not have any idea or doesn't have any information about any of the products that he or she is supposed to see. But we assume that the platforms knows the preference weight of the products, and then the platform can
Tell me
access
what
such
is WI?
information
I'm getting
by,
distracted.
we are analyzing the historical data set that it has access to. Okay, so now let's talk about this two-stage search model. We assume that the consumer learn about WI and ZI in a two-stage process. In the first stage, the consumer is going to screen the products to learn about their preference weights. And then after that, the consumer forms a consideration set. This is going to be
By the way, the
products
way
that at the end of the day, the consumer
they wrote this utility is log WI plus ZI. I don't know how they started to establishing the model, but this form leads to that Gumbel distribution, because look at the PDF. So you want to have some linear form plus some log form.
Consider purchasing. In the second stage, the consumer is going to learn about the idiosyncratic part of the products within her considerations. And after these two stages, the consumer is going to choose the products that is going to give her the highest realized utility. And to make sure that we allow the customers to leave the platform without making any purchase, we also have this outside option whose weight is normalized to 1. Okay, so
ready to be an e-commerce pioneer? Bluehost has step-by-step WordPress onboarding to make creating and running a great...
Okay. So here's our model. We have different from Gumbel distribution. But what is important is that for you and capture the idiosyncratic taste of different consumers. Second term is the idiosyncratic part of the utility that is different across consumer, and the idiosyncratic utility prefer two terms. The first term, which is the log of WI that we refer it to as preference weight of product I, is called intrinsic utility. This is the part of utility which is the same across all the consumer. And the second...
Guys, is it copyright if I am showing you this? I don't know. I don't know if it is copyright or not. Well, you can see their channel, right? ACM, SiteGcom, and all of these are here. So, yeah, go to the page of to their page.
Term is the idiosyncratic part of the utility that is different across consumer, and we put it there to capture the idiosyncratic taste of different consumers. So WI, or these preference weights, are derived from some distribution. The platform can access to such information by via analyzing.
What is WI? You gave us an example. What is WI? What is ZI?
Okay, so now let's talk about this two-stage search model.
Okay, it's important. First stage screens product to learn WI. Consumer does that and forms a consideration. There is only one consumer. Second stage learn ZIs the products in her consideration set. What is a ZI of a product? I don't know.
Learn about WI and ZI in a two-stage process. In the first stage, the consumer is going to screen the products to learn about their preference weights. And then after that, the consumer forms a consideration set. This is going to be all the products that at the end of the day, the consumer is going to consider purchasing. In the second stage, the consumer is going to learn about the idiosyncratic part of the products within her consideration set. And after these two stages, the consumer is going to choose the products that is going to give her the highest realized utility. And to make sure that we allow the customers to leave the platform without making any purchase, we also have this outside option whose weight is normalized to 1. Okay, so now let me give you more information about the consumers. We assume that we have K types of consumers. And these consumers are different in terms of their search costs. we have this screening cost for every position J, which we denoted by SJK. And we assume that the top positions are the ones that they have lower search costs. And that makes sense because the top position are the ones that they are more visible to the consumers. And
Guys, let's not touch the phone. I got an idea in my head, but fuck it. Losing an idea, I lost thousands of them. I don't give a fuck about them. If it's a good idea, if it sticks to my mind for an hour.
This assumption is also in line with the marketing literature that they use the data to estimate these search costs. And then another assumption we make is that the consumers of type K is less patient than the consumers of type K plus 1. So what is important here is that the platform does not observe the type of consumer is search costs. And then and that makes sense because the top position are the ones that they are more visible to the consumers. And this assumption is also in line with the marketing literature that they use the data to estimate these search costs. And then another assumption we make is that the consumers of type K is less patient than the consumers of type K plus 1. So
what is SJK? Screening cost of type K consumer for position. Oh, we have K types of consumer, which is interesting, which I like. Which let us, we have different types of consumers, which is interesting, which I like because it let us to consider targeted advertising. Let me add it here. Actually, maybe I had it before. Well, we had the idea in our mind for sure. Now it's better. Now we know that other people also are. So before we had coding, we said sponsorship, starting point. Anybody has his own crowd. That was something we are interested. And I add, you can have again K type of consumer. And also targeting. That's really where I think targeting is where really is it though? Yeah, okay, about targeting. Targeted advertising. Let me add a page here. So about targeting, I think we can have two things come to my mind. One is targeting is good. Like there are consumers who know what they want to do, right? Who know what they want to do. For example, they want to buy a bottle of water, right? So and if you are a firm that produces bottles for water, you probably you don't want to go and do a blind advertising, right? You want to find those people. If you can send your advertisement to those people, it will be much better, right? It is one thing that platform can really help. Based on the platform's history, they have good knowledge, probably, who is looking for it, who is looking for a bottle of water, or at least maybe you say, oh, consumers go search bottle, but like let's consider Instagram's ads, or when you go on Amazon on the first page. On the first page or on the Instagram, when they listen to your conversations daily, so they know what you want, what you're about, and they will connect that product to you. So in this way, the company or the firm doesn't spend money advertising to people who do not like it. There are some privacy issues here for the consumer who is interested in the bottle of water, but also other people won't be spammed. The same consumer won't be spammed too, right? People don't want to get ads that are not related to them. So about targeting, one is connecting a product to a consumer that wants them. There is one aspect of it which is this, but I believe there is a second aspect too. What is the second aspect? I think if you just think, okay, there is this aspect, there are people who know one bottle of water, and our firm should just focus on finding them and try, and we do an easy sale of, because they want it, we have the bottle, sale will be easy. But there are also cases, I believe the other point we can consider in targeting or blind advertising is related to that, is that some people don't want a bottle of water, but like it happened to me so many times. You go on Amazon puts something in front of you, you didn't have the, or on YouTube all the time. You go on YouTube to watch a video, right? That you want to search about something, but because you go on the first page of the YouTube, there are 6 videos which are suggesting different topics, and I don't know, for me it's just because entertainment or something, I click on it and I get lost in a like huge list of videos, and I watch and I forget the main reason I came to YouTube, the very reason that I started opening the YouTube. I don't go look for it. I watched 30 minutes of videos. I don't, or like walking to a shopping mall, right? You go there, you may want to buy, or a store, you may want to buy a shirt, but you go to the shopping mall, you find, oh, they have a nice jean or a jacket, and you say, I may buy that one too. Sometimes consumers do not know that they want something. Some consumers do not know that they want something, and once they see that this is possible, there is such a thing, there exists such a thing, they buy it. So targeted advertising is good in a sense, but in another sense it may not be good. Like we should keep doing targeted advertising. We should also do like a broadcasting or blind kind of advertising, because people who may not be interested, but once they get to know that this product exists, they want to buy it. Right? Something like ChatGPT, by the way, right? Yeah, most of this stuff, this fancy stuff that we don't die if we don't have them. Some people may need it, some people may need it really hard, and they make it, or even iPhone was that like that, right? We didn't know we need a smartphone. Some people invented it, and we said, oh shit, this is what we really need. At the first date, we didn't know that we need a smartphone. And they made it better, and now we cannot live without it. So they created this need. That need didn't exist in a sense. And maybe something, oh, after a while you see everybody has it and you have to buy it, right? So there is this aspect too. But how is that related to this project? Oh, we were talking about we have K types of consumer. Okay, having K types of consumers, how correct is that? Well, here is a model. We allow some simplification. Gary used to say we have K types of consumer. But in general, I believe if you want to have a model, it's better to say, okay, we have K, for example, type of consumers. Each type really wants something bad, but they also, once they see other results, other products, they may say, why not? I will buy it. Okay, these are the stuff we can think about.
What is important here is that the platform does not observe the type of consumer, but the platform knows the type distribution. And the fact that the consumer does not observe the type of consumer makes the problem actually very challenging for the platform, because now the platform needs to offer a ranking of the product that pleases different type of consumers that have different patience level. Okay. So now you know I described the model. Let's focus on the optimal search strategy of the consumer in the two-stage search model that we proposed. So and I'm going to focus on the first stage where the consideration set is being formed. So to form a consideration set, consumers are going to undergo a sequential search process. At every stage of this search process, the consumer decides whether or not to stop her search. And if she continues the search, she decides which position to screen next.
Dude, I'm thinking about the message I should send Andy. Don't look at your phone. Once you started, you're just fucking don't look at your phone.
We know the college application process can feel overwhelming. Admission.
And the objective function of the consumer is going to be maximizing her expected welfare, where her welfare is the expected utility of the purchased product minus all the search costs that the consumer needs to pay in order to screen the different products. And note that this utility that I have here is the final realized utility. And because of that, when the consumer needs to decide how to conduct her search, she also needs to consider the second stage where the idiosyncratic part of the utility will be realized. So here's our main theorem for this part of the result. So we show that the consumer optimal search policy is an simple index-based policy that I'm going to describe.
Okay, one second. Index-based policy. What does that mean?
So to explain this, so here's our main theorem for the search process consideration set is being.
Sequential search process. She decides whether or not to stop her search. If she continues, she decides which position to screen next.
So to form a consideration set, consumers are going to undergo a sequential search process. At every stage of this search process, the consumer decides whether or not to stop her search. And if she continues the search, she decides which position to screen next. And the objective function of the consumer is going to be maximizing her expected welfare, where her welfare is the expected utility of the purchased product minus all the search costs that the consumer needs to pay in order to screen the different products.
What is the search
And note that this utility that I have here is the final realized utility. And because of that, when the consumer needs to decide how to conduct her search, she also needs to consider the second stage where the idiosyncratic part of the utility will be realized. So here's our main theorem for this part of the result. So we show that the consumer optimal search policy is a simple index-based policy that I'm going to describe in the next slide. So to explain this index-based policy, just to ease the discussion, I'm going to assume that I only have one type of consumer, but of course, whatever I'm saying can be extended to more than a single time.
More than single time.
So in this index-based policy, for every position J, we have an index Rj, where this index Rj depends on distribution of the preference weights f of W and the Gumbel distribution, and also it depends on the search cost.
I don't know why their story is so complicated. And she doesn't give us a
crucial
clear...
here is that if you have a position that has a small search cost,
like it's an 18-minute
be also larger for that
presentation. But to be honest, I
so
don't get it.
in this index-based policy, the consumer is going to start examining the position from the top, because the products, in fact, the consumer is going to examine the product in decreasing order of these indices. And because of the top position has the smallest search cost, that means that the consumer is going to start from the top. So the consumer first is going to learn about the preference weight of the product in the first position. And then she's going to stop if W1 is going to be greater than the index of the second position. And if the consumer stops, the consideration set of that consumer is going to only be the product in the first position. If she does not stop, she's going to learn about W2, and then she's going to stop if some of the W1 and W2 is greater than the index of the third position. And then this will continue. If she does not stop, she's going to go to the third position, because the third position has the third highest index for the consumer, and then she's going to stop if some of the W1 and W2 and W3 is greater than R4, and this process will continue. Okay, so remember, at the end of the day, after learning about this preference weight, the consumer is going to go to the second stage to learn about the idiosyncratic part of the utility, and then after that, finalize her decision. A couple of things that I want to highlight here is the following. So first of all,
I didn't get their model.
If we put a really good products in the top position, I mean by good products, the products that has a really high weight. So by doing so, the consumer is going to have a small consideration set, because it's become very likely that one of these stopping rule is satisfied earlier on. And the other thing is that, as I mentioned earlier on at the beginning of the talk, so the products that we put in the top position impose externality on the products in the lower position. And in fact, the better the products, the higher their rates, the higher the externality is going to be. And finally, another important thing, which is a novel aspect of our model, is that here in our model, the formation of the consideration set is endogenous and is a function of ranking itself. So if I change the ranking, the set of the products that the consumer is going to consider is going to be different. Even the size of that is going to be different. So in the interest of time, I'm not going to go over the related literature, and I'm going to jump into them. In the interest of
Position auctions. Nice. They are auctioning for their position. You know, there is actually what Google does these days is that these people who are like these companies, they don't know how to bid in these auctions, and Google gets some money to bid for them on Google's auction. Empirical work on product ranking. I'm interested in that. Consumer search behavior, interesting. Choice modeling and assortment planning, interesting.
Time, I'm not going to go over the related literature, and I'm going to jump into the platforms problem. And then, and at the beginning, I'm going to focus on the first objective, which is going to be maximizing market share. So when it comes to the platforms problem, one thing which is important is that the platforms knows more than the consumer. The platform has access to all the information about the preference rates, and the platform would like the first objective, which is going to be maximizing market share. So when it comes to the platforms problem, one thing which is important is that the platforms knows more than the consumer. The platform has access to all the information about the preference rates, and the platform would like to use that knowledge to find the ranking that maximizes the market share, which is going to be the probability of purchase. So we have this theorem that says, unfortunately, this market share rank maximization problem is hard, even if we have one type of consumers.
Unfortunate.
This is how AI optimizes my schedule. So I have a project coming up, so I start by listing the project and then setting a deadline. Every task manager does that, but here's where it gets really powerful.
Okay, so then it is so then we are going to focus on designing approximation algorithm. And one natural candidate is the greedy algorithm that just simply sort the products in decreasing order of their weights. And the greedy algorithm is, from the practical perspective, is very appealing because it does not really need to know anything about the consumers. It only needs to know the preference weights. But then
greedy does not need to know anything about consumers, servers, and decreasing their weights. Greedy algorithm is not engaging enough.
I know that our NP hardness results shows that the greedy algorithm is not optimal, but then you may wonder intuitively why it's not optimal. So the reason greedy algorithm is not optimal is that the greedy algorithm is not engaging enough. So greedy algorithm puts really good products in the top position, and because of the stopping rule that the consumer is going to follow, by putting the good products in the top position, the consumer is going to have a small consideration set. So, but you may also wonder, how does it perform? Because a lot of online platforms use greedy algorithm in practice. So we show that the greedy algorithm has a good performance, and then the greedy algorithm is getting at least half of the optimal and opt minus 0.17, and this bond that I'm presenting here is actually tight. So then the next question is that, can we do better than the greedy algorithm? And the answer is yes. We designed a p-task for this rank maximization problem, which complexity scales quadratically in the number of types. The idea of this p-task is based on some
quadratically in the number types. P-task. What is p-task? As a Middle Eastern, I don't know what is p-task. Polynomial time approximation scheme. Oh, okay, because quadratically number of
bucketing procedure that you are rounding up the weights. But just following the simple procedure is not going to work out, because the error in the rounding weights is also going to impact your estimation for the consideration scheme. And then as a result, we needed to restrict this dynamic programming that we run on top of this bucketing approach to follow the low weight priority rankings that I'm not going to go to the details, but if you are interested, I think that's an interesting novel aspect of the proof and the design of the PTAS.
Of course, if you are interested,
So
that's an
the
interesting
next
part.
objective that we focus on.
Of course, if you are interested, that's an interesting. Your art is to make it interesting for people who are not interested. I am going to read this paper anyway. But will other people do that?
Maximizing consumer welfare. And for maximizing consumer welfare, we have this result. NP hardness is still there. Greedy algorithm performs pretty well. And we also design a p-task whose complexity is scaled linearly in the number of types. The previous p-task, because of the search cost in the objective function, is not going to work. And we needed new idea to design.
This guy looks like
okay, so let me
who is the guy? Braveheart? Is that the name of the movie? Yeah. Mel Gibson. Mel Gibson. This guy looks like Mel Gibson.
Conclude. We designed a new two-stage consumer search model that captured product externality, the product externality on lower position. And then we show that under our two-stage search model, the formation of the consideration set is endogenous. And then if the products see better products, they are going to stop their search earlier on. The main insight here is that even if the platform wants to maximize its market share or maximize its consumers' welfare, ranking products in decreasing order of their weight is not going to be optimal. But nonetheless, this greedy algorithm and ranking in that way is it has a good performance guarantee. And we also design an approximately optimal algorithm for both of the objective, market share maximization and consumer welfare. So thank you very much. This is my email in case you have questions, and this is a link to the paper. Thank you.
Thank you. Okay, cancel. Control Shift 1. Well, what I want to do is reading the paper for sure. Because I didn't get what she meant by the utilities. And then
you can view both primary and supplemental materials.
Let's go maybe.
Abstract. On online platforms, consumers face an abundance of options that are displayed.
How long is this text? Alright, it's enough for today. Come back again. Oh, you were not watching it. Alright. Thanks a lot, guys. It was good. I loved it. I loved we found a paper where the first paper was not related, but you may say, oh, we wasted our time. I don't know. Yeah, we wasted a lot of time. But somewhere in the middle of the first presentation, we found out that there is another paper, product ranking online platform, that may be closer to what we want to do. Right? Look, all the way we came. First, how did we find her, actually? I don't remember. Oh, okay. The story starts here. We wanted to go to Amazon. Went to Amazon's page on MIT. Then we found her. Then we went on her list of papers. We found one paper which was related about fake users. Then what happened? We said, okay, it is related, but fake. I don't want to think about fake. And it was a huge paper. It was 114 pages paper. Then we were in the middle of the video she presenting about that paper, the first one. we find out that she has another paper more related. We watched this presentation, we find out this is can be close, but I didn't get the model fully, so we are going to have the paper. Thanks and hope to see you again. Happy Friday, happy birthday to me. Happy everything, happy to bottle of water that you can find on Amazon for $17, and I'm not sponsored by